We're going to continue with the review, and now I have problem number 9. It's asking me to solve 5x squared plus 4x equals to 23. In order to solve this problem, I need to have this equation equals to 0. So I need to move 23 to the left side of the equation. So in this case, 23 is positive, so I'm going to use the opposite number, minus 23. So I'm going to have 5x squared plus 4x minus 23 equals to 0. In this case, my first attempt was to do trial and error or Xbox, whatever you want, but you cannot factor out those numbers. So in this case, my next step is try the quadratic formula. Remember the quadratic formula from problem number 8. So I have that x is equals to negative b plus minus the square root of b squared minus 4ac over 2a. In this case, your values of a, b, and c. A is equals to 5, b is equals to 4, and c is equals to negative 23. So we're going to plug in those numbers in your quadratic formula. So x is equals to negative b. B in this case is positive, so I have negative 4. I'm not going to use parentheses because it's positive, so you don't need to simplify the signs. Plus minus square root of b squared. B is positive, so I have 4 to the second power. You can use parentheses if you want. Minus 4 times a times c is negative 23. So I close the radical. So let's simplify over 2a, 2 times 5. So let's simplify. So I have that x is equals to negative 4 plus minus square root of 4 squared is equals to 16. Negative and negative, see, I'm going to simplify the negatives. Negative and negative is positive, and then you multiply 4 times 5 is 20. 20 times 23 is equals to 460. And this is over 2 times 5 is 10. Okay, let's simplify what is inside the radical. So I have x is equals to negative 4 plus minus square root of 16 plus 460 is 476 over 10. As you can see, my radical is, what is inside the radical is positive, so I'm going to have 2 real solutions. So I'm going to continue here on this side. So x is equals to, so I have negative 4 plus minus square root of 476 got a perfect square. Remember to use your tables. You have your formulas with you. You use your table. And 476, the perfect square is 4 times 119. So in this case, over 10. Where is the square root of 4? Is 2. So x is equals to negative 4 plus minus the square root of 4 is 2 square root of 119 over 10. And the final step is simplify. As you can see, you have negative 4, you have 2, and you have 10. So think about greatest common factor. What will be the greatest common factor between 2 and 4 is 2. So you simplify with the 10. So what will be the final solution in this case? X is equals to negative 4 and 10. So if you only simplify 2, so you have negative 2 plus minus 2 divided by 2. Let me put it over here. 2 over 10 equals to 1 over 5. So it's only 1 square root of 119 over 5, because we only use 10 is 5 times 2, so you only simplify the 2. So in this case, your solution, if you put it in brackets, 1 positive, 1 negative, you have 2 solutions. So you have negative 2 plus minus square root of 119 over 5, comma, negative 2. Well, this is positive. This is the positive minus 119 over 5. And that will be your solution for problem number 9 using the quadratic formula. Let's do problem number 10. Problem number 10 is another problem that you can use quadratic formula. You can use, in this case, simplifying like the square root method, for example. So you have solve 3x squared equals to 36. So 3 is multiplying x squared. So it's going to be dividing to the other side. So 3 goes away. So you have that x squared is equals to 36 divided by 3 is equals to 12. Then we use the quadratic formula, the square root method. So you have plus minus. So x squared, the radical goes away. So you have that x is equals to plus minus square root of 12. We know that 12 got a perfect square is 4. So x is equals to plus minus 4 times 3. Let's simplify that 4. So x is equals to plus minus the square root of 4 is 2 square root of 3. And that's your solution. You have two real solutions. So we use the brackets. So I'm going to have negative 2 square root of 3 and 2 square root of 3. And that will be your solution for the equation of problem number 10. So I hope you have a wonderful day.